Hello, Ubaldo Costa greets you again. I hope you're ready to start with this lesson. We're going to study the subject of stack and heap memory in Java. Are you ready? Let's go. Stack and heap memory in Java. As in many programming languages, RAM, random access memory, is used to store the information of our program while it is running. Java executes a process, and internally there are two classifications to store the values of our programs. These are known as stack memory and heap memory. Stack memory is used to store local variables and function calls in Java. The variables stored in this memory space usually have a short lifespan, only while the function or method in which they are running ends. Heap memory is used to store Java objects, including their attributes. Objects stored in this memory space usually have a longer duration time. This means that the variables that we create, as we can observe in the figure, do not store the object in itself, but only keeps the reference of the object. In the figure, we can see that the reference of the object is represented by hexadecimal value 0x333, which contains the memory address where the object is stored, and therefore the local variable p1 stores only this memory reference. So we can see the stack memory and the heap memory. In the stack memory, we can see the local variable p1 stores the reference of the object, and in heap memory, the object is stored in the reference 0x333. This is just an example. This is very important for issues such as the collection of objects in Java, because the garbage collector can only remove objects that are not being pointed by any variable. In this way, the garbage collector can search for those objects in the heap memory that are no longer being referenced by any other variable and finally free a space in memory that occupy that object. With this, we can add another important distinction between class and object. A class defines a type to be later instantiated, that is, with the objective of creating objects. This means that an object occupies a real space in memory, and it's the object that we will use in most of our programs to send and receive messages through the use of their methods. Assigning memory references. In the code, we are creating one object but two variables, and both of the variables are pointing to the same object. And we can see in the figure, we are creating one object, and we have the reference 0x333. We have the attributes of that object, all stored in the heap memory. And on the other hand, we have the stack memory, where the local variables are created, and we are creating the first variable p1 of type person, and is pointing to the object. And we are passing the same reference to the object p2. Therefore, both variables are pointing to the same object. Unlike what we might think, in Java a variable of type object only stores a reference to the object that are created. So the second line of the code shown, only what it does is pass the reference that is stored in the variable p1, and therefore now there are two variables that are pointing to the same object. That is, that both variables can access what the object allows according to the defining class, for example its attributes or methods that have been defined. It's important to note that a second object is not being created, since there is only one call using the new operator, and therefore there is only one object created. What the variable p2 stores is only the value of the memory reference of the created person object. Every time we use the word new, we will receive a new memory reference, so it's important to know this, since until that moment a new object will be created and not before.